right, we'll get started and hopefully more will join us. So welcome and thank you everyone for joining us today. This will be our last seminar of our Science Speakers webinar series. And if you're new to this series, we're glad you're here, but we hope you'll check out our previous presentations posted on our website and YouTube channel. And we've invited pioneering polar scientists to educate us on their novel applications of remote sensing data. So Dr. Mark Salvatore mapped Antarctica microbial mat communities from high resolution imagery. Dr. Anna Liljedahl developed pan-Arctic imagery products via the Permafrost Discovery Gateway. Dr. Chun-Li Dai measured topographic change caused by volcanic eruptions and landslides from Arctic DEM. And Dr. Ellen Enderlin analyzed icebergs elevation time series from PGC elevation data. Today, it's with our great privilege to end our series this season with our longtime Antarctic operations collaborator and partner across the pond, Andrew Fleming of the British Antarctic Survey. So first off, my name is Kathleen Torres-Parisian. I'm a PGC user staff member, but I also coordinate PGC's education and outreach initiatives such as this. So before we get started, I wanted to share with you some information about viewing the webinar in Zoom. All participants are muted throughout the webinar. We will have time at the end of Andrew's talk for a Q&A, so feel free to submit your questions in the Q&A tab. Please note we are recording this webinar and we will make it available on our website and YouTube channel, as are all of our previous webinar presentations. See if this is working. There we go. So before Andrew showcases his revolutionary work in Antarctic marine operations and consequently science, I want to provide a brief introduction on the Polar Geospatial Center. So for those that have attended other presentations in this series, my sincerest apologies, as this is the same information, but I will be brief. So we are a polar science logistics support organization at the University of Minnesota. Our core funding is provided by the National Science Foundation's Office of Polar Programs. However, we do receive other funding, including NASA's Cryosphere program. So our mission is to provide domain and institutional knowledge to solve a broad range of polar geospatial problems, to provide access to sub-meter commercial satellite imagery over the poles, and the expertise to task, manage, and process imagery and other high-level value-added products. And then lastly, to provide educational courses and online materials to transfer our knowledge and experience to the community, which is what we're doing right now. So PGC's main products and services that enable our mission to come to light can really be described best by these four categories: satellite imagery, terrain models, digital maps, and geospatial support. We have access to a lot of high-resolution sub-meter commercial satellite imagery from Digital Globe, enough to cover over 95 Arctics and over 90 Antarctics, basically over 6 times the surface of the Earth. Another major product and service PGC provides are terrain models, and elevation data is central to many science and logistics projects, and we've partnered with other public and private institutions to automatically produce freely available, high-resolution, high-quality digital surface models using that abundant Digital Globe imagery. So this data has endless potential, and we hope you'll visit our website to learn more about these openly available data sets. So PGC stores and distributes polar geospatial data developed in-house and from external sources, including BAS. So at PGC, we know maps are important tools, not just pretty wall hangings. And we have hundreds of contemporary and historical polar maps searchable online in our map catalog, among several other online geospatial databases. So we definitely encourage you to check out our website at pgc.umn.edu. It has exhaustive information about PGC, our data, our services, tutorials, etc. So please check it out after Andrew's talk. So looking at PGC's role to scientists, we have a breadth of users from the general public to Antarctic pilots, to ornithologists, to cooperative agencies. And our role to scientists is essentially all geared to providing geospatial expertise to enable scientific objectives and hopefully to help users reach them more effectively and efficiently. We spend our time processing and manipulating data so researchers can spend their time on their cool science. So a little background about this webinar series. So Andrew is our 5th and final speaker, at least this season. And I highly encourage you to check out our previous speakers and on our website. We're really excited about these, and we've had really positive feedback from both attendees as well as our speakers. But because of these unprecedented times, many of us are working from home. Much of the Arctic and Antarctic field seasons were canceled or significantly altered in some way. And so we're just trying to find ways to adapt to this. We thought this would be a great opportunity to showcase and achieve community building through our users' research. So our users and collaborators are leaders in innovative thinking and use remote sensing techniques to discover and, like Andrew, enable more and safer science. So stay tuned for future webinars and workshops coming up this spring. These will be announced on our website and our newsletter and social media. So we're absolutely overjoyed to have Andrew as our guest speaker today, featuring his work that impacts an expansive network worldwide of polar ventures. So without further ado, I'm pleased to welcome Mr. Andrew Fleming. He is a research and remote sensing manager at the British Antarctic Survey, BAS. He has also been a manager of PolarView activities in the Antarctic for over 15 years. PolarView is the leading organization that provides critical data services, delivering real-time satellite monitoring over the cryosphere, and it includes information such as sea ice characteristics, icebergs, snow cover, and the list goes on and on. So Mr. Fleming has been a longtime partner and collaborator to the PGC. He previously served on PGC's Science Operations Committee, an advisory group that provides advice on PGC's direction. So Andrew, thank you for being here and sharing your work with us, with our users and our followers, and I'll let you take it from here. Thanks so much.
Thank you very much, Kathleen. So let me share my screen. Which I don't seem to be able to do at the moment. One sec. Right.
Perfect.
Okay.
Thank you.
That's great. So thank you very much for the introduction and the welcome, and for prompting me to change my my photograph and update that online, as I'm showing every one of the 15 or so years that I've been working with PGC on PolarView. So as Kathleen mentioned, I have been familiar and engaged with PGC for a very long time, and that's been an incredibly fruitful collaboration and very worthwhile. But I'm going to switch from the mainly terrestrial and high resolution satellite imagery that we mainly deal with PGC to a slightly different focus, and that is one offshore for mariners and shipping activities around the Antarctic, and one where we're dealing with an entirely different set of remote sensing data and types of imagery. So what I'm going to do in the next few minutes or so is to walk you through the motivations of why we set up PolarView, what sort of information it delivers, and where the future direction of it is heading to at the moment. So Our motivation at the British Antarctic Survey is one of a science organisation that also has a large amount of logistics and operations activities under the same roof. So whilst we maintain and support a wide range of multidisciplinary science, everything from upper atmosphere, space weather, right the way down through the atmosphere, weather, glaciology, the ocean, and deep earth geophysics, with all living resources in between. We are also have under our roof in Cambridge all of the supporting logistics, and that's running bases in the Antarctic, a number of aircraft and shipping operations, which is the main focus of what I'm going to refer to here. So the graphic you can see is of a new ship. The sharp-eyed amongst you will notice that it's not a real photograph because this ship is not exactly ready yet. It is floating, but not yet commissioned, although we should receive the keys in the next few months. And then she will set off on her sea trials and sea ice trials next year. But prior to the Sir David Attenborough, as she's known, not the other name that got so much media attention in recent years. But prior to this, we had a number of other vessels, and up until recently operated both the Shackleton and the Ernest Shackleton and the James Clark Ross. And the James Clark Ross is still in operation and will be going south this season. So we have an interest in ourselves in providing good information about the sea ice conditions around the Antarctic, because we have a ship that is, or ships that are operating in and around the sea ice, mainly for access to our bases and resupply of bases. And this graphic shows you the location of one of our bases, the Halley 6 base on the floating Brunt ice shelf. But in addition to stationary supply, we also use the vessels extensively for science programs in the Southern Ocean. So for both of those reasons, we need to have good information about the sea ice extent and the type of sea ice so that we can make good decisions about route planning and navigation. As a sideline, of course, and some of you may be aware that our base at Halley on the Brunt ice shelf is on a floating ice shelf, which is developing a number of cracks at the moment. And the sort of monitoring that we use for sea ice also lends itself to monitoring these cracks. You can see the two indicated in the graphic here, the Halloween crack and Chasm 1. The good news is that our base has been moved to the safe side of the cracks and is now in a good position. But nonetheless, we continue to monitor this dynamic area quite actively. So the premise of being able to provide good sea ice information is primarily in being able to support safe and efficient navigation. So sea ice poses a hazard to shipping. You don't need to spin all the way back to the Titanic to find incidents where sea ice and icebergs have damaged or sunk vessels. And therefore, it's a primary concern of all mariners to make sure that they are aware of the conditions that they're operating in and make sure that their vessel is within the limitations of the sea ice that they're operating in. So there's a huge safety aspect to this. The other one is an efficiency question. So we want to make sure that where possible, we make good route choice decisions and support good route choice decisions to allow efficient navigation. We don't want to spend too much time in sea ice unnecessarily because it slows the ship. Fuel burn in sea ice is much more significant than it is in open water, and therefore unnecessary transit through sea ice is a waste of fuel and a waste of time as well. And that's money and time that can be invested in other activities such as the science program. So both of those aspects mean that we need good, timely, up-to-date information about the sea ice conditions. This graphic, by the way, is of the Ernest Shackleton, previous vessel of Bass's, in sea ice in the Weddell Sea, and I'll come back to this a little bit later on. So there are a number of changes going on that prompt us to deliver. One of them, and I'm switching to the Arctic here briefly, is changes in the sea ice themselves.
Andrew, I'm sorry to interrupt. It's difficult to hear you.
Sorry, can you hear me now? Is that better? Okay.
Thank you.
So one of the changes that we have to accommodate, and switching to the Arctic briefly, are changes in the sea ice itself. So it's well documented and published how the extent of Arctic sea ice is changing, and that's led to a number of potential changes in shipping activities around the Arctic. But not only the extent is changing, but the age of the sea ice is changing, and that changes parameters such as the type of vessel that's able to navigate and operate in the Arctic. The Antarctic is a slightly different situation in that the extent of sea ice in the Antarctic had been pretty consistent over recent years, certainly over the satellite record, which extends back to the late 70s. And the graphic on the left, you can see, courtesy of NSIDC, shows a relatively stable situation in terms of the Antarctic sea ice extent. However, that has changed in recent years. There's been much more dynamic picture and a reduction of the sea ice extent. In particular, if you look at the Weddell Sea, and that's a primary area of operation for bass, then there's been a significant reduction by about a third in the Weddell Sea summer sea ice in the last few years, largely due to a number of large storms that moved through the area a few years ago, the opening of a polynya in the Weddell Sea, and those reduced sea ice extent have persisted. It's unclear whether that's going to continue or whether it's part of a longer term decline, but it's certainly clear, and I hope the graphic in the center indicates that it's not an overall uniform picture either. It's very much a regional differences in terms of where sea ice may continue to expand or where it is reducing. So the picture is not as, if you like, straightforward as a reducing sea ice extent in that we can see in the Arctic, but very much a regional differences and much more dynamic in terms of the sea ice extent in recent years. All of which means that mariners are having to cope with differing conditions from year to year, and that's on top of a very of significant changes on an annual basis, i.e. the sea ice in the Antarctic changes dramatically throughout the year, almost totally disappearing during the summer months and then growing to double the size of the continent almost during the winter months. So significant changes to be coped with. So that's change number one. The second change, switching back to the Arctic again, is the level of traffic that is using or transiting through or around the polar regions. So this graphic shows some ship tracks around Svalbard in the Arctic, and you can see the main shipping routes around the coastline there, showing the main routes used by ships. This data is plotted from satellite AIS data to give an indication of the actual tracks of a number of ships. This one for tourist vessels in 2018. But interestingly, off to the northwest of Svalbard, you can see a number of tracks that extend out towards the sea ice edge, which is indicated, a general position for the sea ice edge indicated by the orange line, indicating that ships transiting out towards the sea ice edge and then returning back in again. And these are tourist vessels, so in part these are voyages designed to go out to the sea ice edge, see the sea ice, and then return back again. So the volume of traffic is changing as well. The volume of tourist traffic in this instance, but also the volume of other types of traffic, either transiting through cargo routes, transiting through the Northwest Passage and the Northern Sea Route, or other types of vessels. And whilst this is the Arctic, the same increase in traffic is seen in the Antarctic as well. And if you can look at the tourist vessel numbers reported in the Antarctic by the industry body IATO, showing an increase in tourist numbers. And with that comes increased risk. And I mentioned that you don't have to go all the way back to the Titanic to see the latest, a more recent vessel that foundered thanks to sea ice and icebergs. And this is the MV Explorer, which back in 2007 sank in the Bransfield Strait, just on the northern part of the Antarctic Peninsula, having hit a piece of glacial ice in amongst sea ice. So in this case, this perfectly highlights the safety aspect of knowing the extent and the position of sea ice and icebergs in the region in order to inform shipping behaviour. And then the third change that I've referred to as changing the regulations. So a number of you may be familiar with IMO, the International Maritime Organization, and they've recently introduced in the last few years a new set of regulations called the Polar Code, designed to provide guidance and regulations to improve the safety of shipping in the polar regions, specifically tailored to the polar regions. Part of this actually mandates that ships coming under the Polar Code need to have access to good information about the environment that they're working in, including the weather and sea ice conditions, and also a system that allows them to assess the risk of their particular vessel operating in the sea ice conditions that they find themselves in. Again, I'll come back onto that in a few slides' time, but this is another significant change in recent years, is the actual regulations that are required. So in response to all of this, and in response quite a long time back, since back in 2004, when in the Southern Ocean we didn't really have access to any good regular sea ice information. It's not the case that there was a national ice centre producing regular sea ice charts, as there are in the Arctic. All Arctic nations have an ice centre that produces regular ice charts, and have been doing that for decades and issuing them to ships over the recent decades. And that didn't exist in the Southern Ocean, and therefore there was a relative lack of good information. So as part of a European Space Agency funded program called PolarView, which already existed, we decided to propose extending a service into the Southern Ocean to address this relative lack of timely, near real-time sea ice information. So that's what we did, and we set out to establish a single point of access for as much relevant information as would be useful to ships, and consider how to deliver that directly to ships. So PolarView for the Antarctic in the Southern Ocean was established in 2004 and has been operating ever since, primarily with the aim of making sure that all ships have access to safe and efficient, so information to support safe and efficient shipping. So I mentioned that our motivation at the British Antarctic Survey was because we have ships ourselves, but clearly it made no sense to set this up and restrict the information just to ourselves. So it was easier, in fact, to make sure that this was open and accessible to everyone that could use it. And that includes not just other national operators and research vessels, but every type of vessel operating or user operating in the Southern Ocean. And it's now used by quite a wide range of users, including whether it's commercial shipping, tourist vessels, fishing vessels, as I said, other science vessels, and the rescue coordination centres make use of it as well. And any ice service that is working in the Southern Ocean, or now delivering sea ice information in the Southern Ocean, also uses it. And we don't track individual users. It's free and open at the point of access, but various reliable web stats would give us an indication of several thousand unique users per month, pretty much year round. There is an Arctic version of the Antarctic service as well, that I won't highlight here, but for every graphic that you see as Antarctic, there is an Antarctic one. So PolarView is delivered primarily through a web portal such as this with an interactive map display. where you can layer the various bits of information on top of each other and get a good idea of what information is delivered. So I'll walk through quickly what types of information are provided here, but please feel free to go and explore yourself. The URL is provided at the top there. And for those of you not familiar, .aq is the Antarctic domain, in case you're thinking that's a typo. So the first type of information that I'll highlight is sea ice concentration data here, derived by the University of Bremen from AMSR2, passive microwave radiometer. And this is updated on a daily basis. We get complete coverage of the Antarctic sea ice zone every day. And it's relatively low resolution, but is independent of any sort of cloud cover and whether it's polar night or day. So this is a reliable, regular source of information. And a number of people would, certainly users in the Arctic would experienced sea ice analysts in the Arctic would not recommend this for detailed sea ice navigation, tactical navigation decisions. But when you have nothing else, it's fairly clear that mariners become adept at using even low resolution information like this. And as I say, given that it's reliably delivered on a daily basis and updated on a daily basis, it at least provides one level of information which is of great use to ships, either planning routes or making decisions on a day-to-day basis in terms of which route to follow. The other and much more detailed, much higher resolution source of information that I'll highlight is the Sentinel-1 imagery. So for those of you unfamiliar with Sentinel-1, this is part of the Copernicus satellite constellation. There's the European funded constellation of satellites. This is the first, Sentinel-1, first in the series, but there are actually two of them in orbit, Sentinel-1A and 1B. And they deliver synthetic aperture radar imagery. So this is radar imagery, i.e. it's entirely independent, again, of the lighting conditions or any cloud or weather conditions. Each one of the little green squares here gives you an indication of where an image has been acquired. This is about 3 days worth of coverage, and the intention of the acquisition plan is that the entire sea ice zone is acquired every few days. So you don't get complete coverage every day, but you get complete coverage every few days. The volume of data would be colossal otherwise, and there is limited capacity on the satellite. It can't be turned on all the time, and it can only be turned on for a few minutes every orbit, and hence we are always trying to work with the European Space Agency to tailor the best acquisition over the Antarctic as possible. So it delivers data like this. It's a black and white monochrome radar image. And I'm hoping what this indicates is its excellent ability to distinguish between different features on the ocean surface. So ignore the areas artificially shaded as blue. Those are the land areas. This image is acquired off the north of the Antarctic Peninsula. And you can see open water on the left, sea ice in a more noisy pattern over the right, and then the occasional large tabular iceberg. There's one top left of the image that you're able to see, and the number of icebergs entrained in the image in the sea ice area itself. So think of these images not as a traditional black and white optical photograph, but more like an image of differing surface roughness. So the ocean surface appears smoother than the rougher sea ice surface, for instance, at this particular wavelength. Another example of this, and some of you may be familiar with this, is the A68 iceberg, frequently referred to as the biggest iceberg in the world. It's not, but it's currently occupying a lot of media attention as it drifts out of the Weddell Sea and into the Southern Ocean, and has been doing this for several years yet, and miraculously remained largely intact and in one piece. But this sort of imagery gives us a great idea of where this berg is. It's about 120 kilometers long, if I remember correctly. And whilst a ship's not necessarily going to be worried about this, it knows exactly where it is, because it's so large. You can also see on the surrounding ocean surface a much larger number of other icebergs that are shedding off A68. So this sort of imagery is excellent, and a huge part of the heavy lifting of the Polar View service is providing this sort of imagery as quickly as possible. And we deliver each one of the images, the little green outline images that you saw a couple of slides ago, within 3 to 4 hours worth, 3 to 4 hours since the acquisition time. It'll be available online. And we do that both for the Antarctic and Arctic. So that's hundreds of images a day, and quite a large volume of data. If I click this, I'm hoping this animation will work, and you should be able to see the changes in this animation. This is a series of Sentinel-1 images over a period of time starting in early 2017, and working our way through. This is the Thwaites, the front of the Thwaites Glacier. Some of you may be aware there's a large project investigating the Thwaites Glacier at the moment, and this just gives you an indication of the large number of icebergs calving off the front. But to illustrate that this type of data is excellent at providing repeat observations. So in the sea ice context, what we can use this for is to get an indication of the sea ice motion. So rather than just giving you a picture of where the sea ice is or was 3 hours ago, we can also give you an indication of where the sea ice has been moving to. So repeat passes of Sentinel imagery give you an indication of where the sea ice is moving to, based on tracking features between the repeat swaths of Sentinel-1 imagery. And this data set then builds up and is composited, as in this example, and the little zoom in on the right, and delivered as part of the Copernicus Marine Service by the Danish Technical University. So that's another level of information to inform mariners where what the sea ice conditions are and how they're changing. Sorry, I should also mention that in addition to the sea ice motion, another step that can go from here and not applied and not operational yet in the Antarctic is to provide a derivative of this motion field, such that you can indicate areas within the sea ice of where the ice is in compression or where it's diverging. And ultimately, when you're looking at the bridge of a ship and you can just see sea ice in front of you all around, and that's what it looks like in the imagery as well. The really key bit about planning a route is understanding where the ice is converging or diverging. So that additional level of information, again, over and above the motion, is hugely useful to mariners. So switching from radar imagery to optical imagery, and this is one example of the optical imagery that we again provide on a routine basis through PolarView. This again comes from the Copernicus Sentinel series, but Sentinel-3. And whilst this suffers, if you like, from cloud cover in places, and you can see the cloud cover, again, you can see that there is, where the cloud permits, it gives a good indication of the sea ice extent and the structure within the sea ice. So this snapshot in the window is again off the north end of the Antarctic Peninsula. And if you look through the clouds, you can again see A68 iceberg just above and to the left of the center of the image. And there again, just zooming in on A68, and a few months back, whenever it was leaving the edge of the sea ice and surrounded by the huge number of icebergs that are coming off A68. So, in addition to a regular supply of near real-time satellite imagery, PolarView also now collates and delivers the formal ice charts that are provided by a number of the ice services which produce ice charts for the Southern Ocean. So for those of you not familiar, ice charts can be considered like a weather chart of sea ice conditions. In effect, it's a expert interpretation, and expert ice analysts will take all the information that they can gather, including all of the satellite imagery, and then produce this interpreted view of the sea ice conditions. So this example is from the Weddell Sea, produced by the Norwegian Ice Service. And the color coding is shows the concentration of sea ice on the surface, i.e. the percentage cover, as one layer of information. But the Norwegians are not the only ice service providing charts of the Southern Ocean now. The US and the Russians also collaborate to produce ice charts of the entire hemisphere, the entire sea ice, Southern Ocean sea ice zone. And this example is from the US National Ice Center, and shows not the concentration this time, but the stage of development of the sea ice, i.e. what type of ice it is, or the what type of ice is in classified by ice regimes, i.e. the main types of ice, whether it's first year ice, multi-year ice, glacial ice, and there's a whole range of ice classifications that a classification that they follow. So this information is produced irregularly. The ice charts are updated only once a week. But it does provide an expert interpretation of the sea ice conditions, and used in conjunction with the more regular satellite imagery is at least a first step towards having a ice service for the Southern Ocean, whereby users have access to some degree of expert interpretation combined with a up-to-date view provided by more regular and timely satellite imagery. I mentioned previously that the IMO Polar Code now mandates users to have a system in place to assess the risk of their operations. The current system in place is called Polaris, and it is designed to allow a ship to say, to understand, based on the classification, the ice classification of the vessel and the conditions that it's currently experiencing, whether it's within or not, or outside of the limits of operation for that classification of vessel, given the ice conditions that it's in. So you can make an assessment of the ice conditions by looking out of the bridge and making a local observation and plugging that into the Polaris calculation, which uses a series of risk indices to calculate whether you are above or below the threshold of limits of operation. But we can also use the sea ice concentration and stage of development information in the ice charts to make this calculation as well, thus providing a calculation and a picture of the Polaris risk over a much larger area. So this example is the traffic light result of the Polaris calculation for a polar class PC5 classification vessel in summer conditions, assuming summer conditions. And you can see there that it gives, for a PC5 vessel, the green areas mean that you would be within your vessel's limitations. The red areas would be areas where you're not within the limits of operation for your particular vessel. And the amber areas are ones where you are permitted to operate, but with certain restrictions in terms of speed of operation. So those Polaris calculations are now automatically plugged in and available on the PolarView website. You can, on the left-hand menu, choose the classification of vessel, your time of year, and it will show you the output risk map. One other layer of information to highlight, we've been referring to sea ice most of the time, but icebergs are another key parameter. And there are two sources of information provided at the moment. One is the tracking provided by the US National Ice Center of the large tabular icebergs. Those are the white and red dots that you can see. And those are really just the very, very large icebergs that you can see. But the Argentine Ice Service has recently started providing a more detailed assessment of iceberg risk and iceberg chart, which is shown in the green, yellow, and red colors off the ice edge there in the Weddell Sea sector, giving you an indication of iceberg occurrence within that area. So again, those are plugged in and automatically updated on the PolarView website as they are produced and updated. And that allows us to keep an eye on these large bergs. In this case, as a quick aside, the A23A iceberg, which was stuck in the bottom of in the southern part of the Weddell Sea and had not moved since about 1986, whenever it first calved, and only in the last few months has decided that it's time to make a break for it and has started to shift for the first time in many years. Maybe it's getting slightly tired of all of the attention that the A68 iceberg is getting, given that this is actually the oldest and is larger than A68. So a lot of the time when I've been referring to sea ice information there, I've been referring to effectively old information, if you like, even if it's only a few hours old. So it's up to date and it's timely, and it's the best information available. But as with weather forecasts or weather information, you might rightly ask about forecasting sea ice conditions. So these examples are of forecasts of various sea ice parameters for the Arctic Ocean. And it is true that some models are currently providing outputs of sea ice forecasts in the Southern Ocean as well. But it certainly seems to be the conclusion of those involved in this, and having come from attending the recent International Ice Charting Working Group a month or so back now, it's the conclusion that sea ice forecasts to be used on a operational tactical basis in the Southern Ocean are not yet to be relied upon. So it's an area of active development, and hopefully in years to come we'll see this sort of information being provided through PolarView. But we do draw the line at making sure that the information that is being provided, certainly the higher level information that's being provided, is validated and QA'd and endorsed by the ice services where possible, since they're the experts in this information. So that's the PolarView service, and as I said, it's primarily delivered through the web portal at polarview.aq. We are conscious and have always been conscious that the information needs to get to ships in the Southern Ocean, which are generally on the end of fairly bad telecommunications bandwidth connections, and therefore we have tailored the service somewhat to low bandwidth by doing a number of things. So the graphic there is a low bandwidth interface, which you can find from the website as well, which is a much simpler and lighter weight version of the website. We also deliver information by providing automatic email notifications when new information becomes available in your area of interest, rather than you having to load up and check a heavy website frequently. And other options such as online streaming of imagery and information tailored to low bandwidth connections, which actually works really well. But nonetheless, we do find ourselves inevitably looking for as good a bandwidth connection as possible, given that the volume of higher resolution imagery is still very large, sometimes compared with connections which can be as low as a single iridium channel at 2.4K. And that then speaks to a couple of future trends and ways of coping with them. So I'll mention quickly a couple of areas whereby we are actively working at the moment, but they will feed through to improving the service that underpins PolarView. So the first area is the sheer volume and number of satellite imagery and coming from the increasing number of satellites available in orbit. So this graphic gives you some indication of the growing number of satellites in orbit, in particular the Copernicus series, which is growing and growing, and there are multiple satellites of each type in some cases. Sentinel-1A and 1B I've already mentioned, but 1C is already slated for launch. So the number of satellites is increasing, and they are delivering more and more data, and a lot of it is relevant and applicable to the polar regions and of interest to mariners. And so the volume is growing, and we have to find better ways of coping with the volume of data and how we process that on a timely basis. So just to give you an indication of where the volume of data has come from, and trust me, there is a very tiny red indicative satellite on the left-hand side, which you probably can't see, all the way through to the volume that's predicted by the end of the next decade. So by the end of this decade. that's one issue we need to deal with. And like a huge number of the space agencies and satellite operators, they've looked to ways of changing the usual way of delivering and processing imagery. So traditionally, users would download the imagery and process it locally and then derive the information they want from it. The model now turns around on its head, and given that the inertia is with the data, leave it where it is and take your code and your processing to it. So this will be a familiar concept to many people, especially those using platforms like Google Earth Engine. And the European Space Agency has been developing similar platforms, a series of which are called the thematic exploitation platforms, which aims to do this, apply that concept in a tailored way to particular theme domains. There are 7 of them currently, one of which is polar, and we are involved in helping develop the polar TEP, effectively to provide a platform that allows processing of large volumes of satellite imagery without having to download it all, an environment where we can develop the various processing routines and chains that we need at the same time as, well, in parallel to not having to download and handle all of the heavy lifting of managing the imagery. So we access it at source, as it were, through the European Commission's DIAS platforms, which provide access to the imagery and access to the necessary compute to do the processing, which takes the load off our local systems. So we continue to develop Polar TEP and work with them to add new functionality. That includes things like integrating with newer data access points like data cubes. It includes working with Canadian projects like the CCADI project, which will provide access to a much larger volume of other polar data to work with alongside the Earth observation data. I referred to the European DIAS platforms, which are the data access and compute platforms that the European Commission have set up, which is the underpinning platform service for this. And we are also now integrating machine learning tools, which brings me on to the second thread of how we're coping with this increased volume of data, and that is turning to a much more automated way of extracting information from the imagery. So to terms in the Earth observation world that everybody will be familiar with these days are artificial intelligence, machine learning, etc. And the British Antarctic Survey has recently set up a AI lab to respond to our growing collection of multivariate environmental data collected over many decades, in order to work out how to best extract value from that using these novel techniques. So a couple of examples of where we've applied this: one, not remote sensing, actually classifying the Southern Ocean using Argo float data, and then one that I've been working on with a colleague, which is using, again, Sentinel-1 imagery, but applying automatic clustering techniques to classify icebergs within sea ice. And so we can detect those, especially in an area where we have no training data, and it's effectively an unsupervised classification approach that we're trying to develop. So these sort of methods will hopefully allow us then to extract a lot more information from the growing volume of information. And there are a number of activities and projects, often involving the ice centers, to work to derive automatically sea ice information, ice charting type information from this imagery to support, or in some cases augment, the manual expert interpretation that is currently the way of deriving sea ice charts. So that activity is underway. And again, just to reiterate the point that we don't anticipate adding these into PolarView until they're fully validated and endorsed by the ICE services, but that will come undoubtedly in the next few years. So I'm going to leave it there and just provide you with one last quick shot from a few hundred meters up rather than a few hundred kilometers up, kind of bringing us back down to Earth, which is another aspect of information that we've been developing over the last few years for sea ice navigation, and that is to, again, augment the wide, relatively low resolution view from satellite with the much higher resolution view from a small drone that we've been using. So we set off trying to do this quite a few years back, and it's now in very regular use from our ships, effectively extending the crow's nest so that you can get a view that's a few hundred meters above the ship, and allows you to see, as you can see here, way over towards the horizon, much further away from the ship than you would do just from the crow's nest, and give you a view in order to spot areas of open water and make good decisions, especially good navigation decisions, especially when used in conjunction with the satellite imagery and other data sources. So thank you very much. I'll finish there.
Great, thank you so much. You've provided so much information about BAS, but also for our users, you know, we often have to hand off, you know, our services that we can't provide real-time information, and most undoubtedly send them to Polar View. So thank you so much for this awesome overview of all of your work, and I will open it up to any questions that we have from participants. And just maybe give a little time in case they're typing those in, but so interesting to hear also about the drones that are being used, because we hear that more and more just from our users that are looking for really high resolution and high temporal data that they can grab. Is there an aspect that you store the drone data as well?
No, we haven't yet, because it's always been just an on-demand aspect. It's we need to see the picture now, and then it's the information is not used thereafter. But there are other developments with that may prompt us to keep hold of it. For instance, flying ahead of the ship and deriving some sort of sea surface height or and derived sea surface thickness type of information is one avenue that might allow us to do that. But most of the time, the drone is really just a quick view. And we do have the ship's captain with a VR headset on, so that he's able to direct the drone himself and decide where he wants to see it. So.
We do have a question that came in. Apologies if you've covered this already, but are any of Polar View's services optimized for low bandwidth users, specifically for teams actively working in the field?
So I'm just making this one Steve up. So yes, I did mention this briefly, that we do have a version of Polar View Online that is trying to be a lighter weight version, so it'll open more easily on the ship. But by far and away, the best option for getting access to information if you're in the field and you need not to be dealing with a heavyweight website is to set up an email notification, and we can, if you contact us, we can set those up. Such that define an area of interest, define the products that you're interested in, and then once a product is available, then you'll receive an automatic email notification with the product attached if possible, or at least a download link for it.
Great, thank you. Also, another comment and question from Paul Moran. Talk about how countries and agencies provide imagery. What does it mean organizationally or technically?
I could be here all day with that one, Paul, as you well know. But I'll mention one thing. So we provide access data from as many sources as possible. And we're really keen to continue to expand that. The primary access points for us are places like NASA and the European Copernicus programs. And the key bit there is that their data policy means that it's open. and we don't have to worry about data access restrictions. So organizationally and technically, that makes things much, much simpler. And in terms of technical access, then that continues to evolve, but the shift to providing cloud optimized access in a way that we can process directly alongside the place of origin, if you like, the data's home, reduces the amount of heavy lifting we have to do. So.
Great. There's another question here. It says, hi, Andrew. Is there a record of historical ship tracks before AIS data around Antarctica?
Some, yes, Alison, and if you drop me a note, and I can update you in more detail from what I know. But there are some records kept because they report sea ice observations along them, and I know those observations have been used in some historical reanalysis programs. So that so there are some, but not many, and I suspect may involve a certain degree of digitization.
Great. Well, we're almost to the hour here. Thank you so much, Andrew. It's always been a pleasure hearing about all what's going on at BASS and Polar View as well. And we will wish you the best for this Antarctic season. And thank you so much for your time.
No problem. Thank you very much. It's been a pleasure.
Oh, maybe there's time for one more question. Sorry, my apologies for bothering you with this following question. I'm an early researcher. I would like you to just guide me to any kind of help or tutorial about processing radar altimeters and laser altimeters.
So I'm going to put my email address in, and I've sent that, and please feel free to contact me, and I will endeavour to point you in the right direction. We don't use a lot of altimetry data through Polar View, but through other channels we do make extensive use of that, and there are certainly people in BASS and in the UK that can help with that.
Great. All right, for real now. Thank you so much.
Thank you. All right, bye-bye.